Hi learners, welcome to the today's topic. I'll discuss about the questions related to question bank, and the topic is classification and prediction. Myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So I am covering all the questions related to what I can do in this half an hour time. So all the questions I'll take for classification and prediction. What is classification? The first question is, what is classification? Classification, originally it is going to predict the categorical levels of data with the prediction model. So there will be a model that is going to predict about the categorical levels. This analysis provides us to understand about the data at a larger scale. Classification model also going to predict about the categorical class level. So basically, in the starting only that has been given, that is going to tell about the categorical type of data classes. The classification is to identify the category, we can say class level for the new observation. So first, a set of data will be there that will be used for training data. And second will be the test data. So whole of the data that will be divided into the two parts. First will be the training data and second will be the test data. The set of input data and the corresponding outputs will be given to the algorithm. So the training data set we will have, that is going to include the input data as well as it will be associated with the other class levels. So using the training data set, the algorithm is going to derive a model. It is going to classify a class level, which is unknown. So the derived class can be that can in the form of a decision tree, that can be in the form of mathematical formula. We can say some of the time it can be also neural network. So these are the few fields of classification. On the type of classification we can do. The derived model can be that decision tree, mathematical formula, neural network. In classification, when unlabeled data will be there, that is given to the model, right? So it should find the class to which it belongs, because we don't know either before the unknown, before we will only having the unknown, the data that is having the one class level missing. So for that we are doing the classification. When we are going to give that record to the that model, so that is going to find the class for that. That is going to find the class level for that in which it belongs. So respective to the other database, it is going to match that. If it is not there, so it is going to make a new class level. So the new data, it is going to provide it to the model for testing of the data. So what is test data? That data that is unknown. The class level that unknown, that is the test data. Next question is, what is prediction? So classification and prediction, that is separate things. Prediction is different. In prediction, we only have to we only have to predict about the nearest point of that particular unknown class. But in classification, we have to match the most relevant cluster of class, right? So prediction is the process of identifying the missing or unavailable numerical data for the new observation. So that is also will work on the numerical data. Prediction model, it is going to predict about the continuous value data, we can say ordered data. So on the data that is basically numerical and that is having the continuous type of we can say the separation from the one data to other. So if there will be the continuous value data, so that we are going to apply the prediction. The training data set here also will be there, that is containing the input and output corresponding numerical output value. The algorithm that is going to derive the model, we can say predictor in this relative to the prediction, that is according to the what the data we are going to give the model, what the data we are going to give the model to learn about that. The model should find a numerical output when the new data is given. So we are going to give the test data on the basis of we can say training data. It is going to give the relevant class level, relevant prediction. In the relative to the prediction, it is going to tell about the most nearest prediction value. For example, a prediction model is there that is going to predict about the expenditure in dollar of the potential customers. So some customers are there for any business model on the computer equipment. So on the basis of income and occupation, if we will have the data related to that, so on the basis of that we can say historical data, what the training data we are having on the basis of income and occupation, these are the two class level. On the basis of that, we are going to tell about the expenditure in dollar. So that is prediction. Next question is, what are the issue there in classification and prediction? So these are the two models that is basically the theme is same, but they work separately. So what is the issue can come between them? So the major issue is preparing the data. While we are going to pre-process the data for classification as well as for prediction, so that is the preparation of data will be the most challenging point. First, when we are doing the data cleaning, in the data cleaning that is going to involve the missing data, that is going to involve the irrelevant data, incomplete data. So the data cleaning, it is going to remove the noise and that missing data. So to treat that data, the data cleaning is process will go on. So the noise will be removed by applying the smoothing techniques. So some of the smoothing techniques are there to remove those missing data, smoothing techniques. So for missing data, incomplete data, irrelevant data, so these are the few things on which the smoothing techniques will work on. And the problem of missing value is solved by the replacing a missing value with the most commonly occurring value for the attribute. So for if missing value will be there, there is another technique. If incomplete, irrelevant and we can say any invalid value is there, then we are going to apply the different smoothing techniques. Second is relevance analysis. What is relevance analysis? So in the database, if in the database there can also have the irrelevant value. There can have the irrelevant value, as I have said about the if data is dirty, if data is noisy, and data is incomplete. So in that process, the correlation analysis is used to know about whether the two given attributes are related, they have any relation between them or not. So for that, the relevance analysis process will work. Data transformation and reduction. So third will be the when in the pre-processing we have to do the reduction of data, we have to reduct the data, and we have to also change the type data format of data. Then that in that process there will be the two following methods. First will be the normalization, second will be the generalization. Normalization. So these are the very important techniques actually. So normalization is nothing but the data will be transformed using the normalization technique. Data will be transformed. So normalization is going to involve the scaling of all values for a given attribute. So all the data what we are having in the training set. So the data will also what is the normalization in the software? all the data will be at a one scale, that will be nearest to one scale, that will be depend on the attributes value. So for a given data that we have to make them fall within the small specified range. So there will be some relevant space, some relevant range will be there, and in between all the values, that will be reducted to the one specified range. The normalization is used when the neural network or the other methods involving the measurement that is going to use in the learning step. So in of the model of the learning phase of the model, that these are the normalization will work. So in basically that will work in pre-processing point. Second is generalization techniques. So in that the data can also be transformed by generalization into higher concept. So for this purpose, we are going to use the concept hierarchy. So what is concept hierarchy? That is a logical logical hierarchy of the all the data. So in that there will be the abstraction of all the data values. Next question is list the comparison of classification and prediction method. So here we have to check the what is the compare between the classification and prediction. So comparison of classification and prediction method, it is having the sum of the criteria on the basis of some of the criteria. We can say that they are like what is the comparison between them, we can say about that. So first will be the first criteria will be the accuracy. On the accuracy of the classifier, that can be referred to the ability of the classifier. What is the ability of the classifier to classify the class level, that is correct or not, that is to specify to classify correctly. And the accuracy of the predictor can be referred to as well as how well a given predictor is going to estimate the unknown value. So that is relevant to the, that is related to the classification for the class level, and the given predictor for the given prediction for the estimate of that value, what that has to be predict on the basis of that, that is telling about the accuracy. Second criteria is speed. The speed of the method depends on the computational cost. So what is computational cost? What is the actual cost while we are going to complete that process? How much time and money it is going to take? So that will be the computational cost of that particular method. So that is going to depend on the computational cost of generating and using the classifier as well as the predictor. Third criteria is robustness. Robustness is the ability to make the correct predictions or classifications. So on the context of data mining, the robustness will be the ability to of the classifier as well as the predictor is to make the correct predictions from the unknown data. So what data we are giving into the test data, that will be unknown. So what will be the nearest prediction, what will be the very accurate prediction, that will call as a robustness of data. Scalability. Scalability is going to refer to an instance increase and decrease in the performance of the classifier as well as for the predictor for the given data, for the given training data. Interpretability. So this is the another criteria to compare the both of the methods. Interpretability is how readily we are going to understand about the reasoning behind the prediction and for the classification. So what is the basically reasoning in there while we are going to do while we are going to give the model, while we are going to give all the values to the model. So before that we have to understand about the reasoning. The model have to understand about the reasoning of that. Next question is, what is random forest? Random forest is nothing that is also a classification model. A random forest is a supervised machine learning algorithm in the that is going to be generally used for the classification problem. It is going to operate by the multiple decision tree. That is going to operate by the that will be the combination of multiple decision tree. decision tree. What is decision tree? What association rules we were going to make in the process of frequent item sets. So for that we have to write association rules before we are going to apply the algorithm. So in that process, the decision tree will be there. So decision tree is nothing but that is tree-like structure, and that is going to depict all the rules in the graphical representation. But random forest is the combination of decision tree. So many decision tree will be there in the one random forest. So it is going to give in the training phase, while we are going to give the unknown value, while we are going to give the all the training data set what we are having to train the model. The random forest, that is going to choose the decision of the majority of the tree as the final decision. So in what is majority? So there will be the voting method. There will be the voting method. On the basis of that, each branch, that is going to be split on the voting system. So if the vote is high for one branch for the one class level, so that particular class level of branch, that is going to be expanded. So in random forest, there is a majority of voting method will be used. What is decision tree classification? So the question is, what is decision tree classification? So as I have told roughly what is decision tree. So a decision tree is going to build a classification model in a tree-like structure. That is having the data sets broken up into the smaller subsets. So that is basically roughly we can say that is a roughly a set of all the smaller subsets of data that is going to develop the decision tree. Literally in a tree-like structure way, that is having the branches and nodes. Decision tree can handle the both categorical and numerical type of data. So that is very, very useful. Also because it is very, very like we can say handy to see the visual representations, and the communication between the business users and the miners, that will be more often. Next question is, explain the k nearest neighbor algorithm. So basically k nearest neighbor algorithm, it is related to classification only. That is a classification algorithm that is working in a way that a new data point that is going to assign the neighbor. So there will be the combination of some data points, we can say class levels. If that is matching at a point, so they will be going to make a we can say they are going to make a sub neighboring system. So they will be if they will be very near to that point, so that will be the a neighbor of that point. So similar to that neighbor. So the new data point that is going to assign to the neighboring group to which it is going to most similar in a way. In k nearest neighbor, k can be an integer that will be greater than 1. So k is greater than 1. So for every new data point that is coming as a unknown data, we want to classify and we want to compute to which neighboring group is the closest. In k nearest neighbor, suppose this is suppose there is an area, there are some points. So what is k neighbor? If from this point we have to check what is the nearest point is there. So we can see this is a very near point, this is very near point, this is also somewhat a near point, but they are nearest point. So they will be the two nearest points. So how we have to calculate this? So there will be the distance measuring system. On the basis of that, the Euclidean and Manhattan, there are techniques are there to calculate that distance, and the basis of that will be the nearest neighbor. That will be the nearest point of that particular this point. So like this, the KNN is going to work. Yes. So let's take an example. We have to classify an object that is using the following example. Consider there are 3 clusters. we have three types of objects there. First is football, second is basketball, and third is tennis ball. So in the right hand side figure, if we have we will see there is a durability and cost in x and y axis. There are footballs, there are basketballs, and there are tennis balls. So three types of balls are there, right? So three of the clusters they are making. Right? Now, so they are nearest. What are the points are nearest to them? Like this. These are the nearest. These are the nearest. These are the so nearest to each. So in between there is no any combination, because if we will cluster these also, but there will be the problem, because that is coming in this also, that is coming in this also. So like this we have to make a cluster that is not disturbing other points. This that can be also combined, but that is not a worth it to combine this. Like this we have to combine, so that will be disturbing element for that. So better to make a simple cluster for that. So here we are, if we will see, there is a black point, so that is a new data. If that there is a new data point, that will be classified as a black ball. So we have to classify it as a, if k is 5, suppose k is 5, we are going to use the kn for to classify that. So next we have to find out the nearest data point in that. So what will be the nearest data point? That. So that is so far, that is far, but that is nearest, right? So like this we have to make. So we have to combine that point, what black point is there in the that particular ball points. So in that same cluster. So observe that all the 5 selected points don't belong to the same cluster. There are 3 tennis balls and 1 each of the basketball and football. So when multiple points classes will be there, that is going to involve, we prefer the majority. So if we will like what it is telling, this and this, and suppose this is like this it is telling up. So if there are these type of clusters, so that will not work. What we have to do here, we have to check the majority of that. So here the majority will go with the tennis ball. So the new data points will be assigned to that tennis ball cluster. So what is the majority of the points, other points, that will also depend on that particular cluster. Next question is briefly explain the logistic regression. So here logistic regression. So this is also the classification algorithm that is going to predict about a binary outcome for a given set of independent variable. So independent. What is independent? What is in regression actually? What is regression? So regression is nothing but regression is that is depending on the independent data that is going to that will be depend on the dependent data. So there will be some graph like this. So on the basis of the dependent data, the independent data, it is going to predict about the predict about the next class level. Now the output of the logistic regression is either can be 0 or 1, because that works like a binary with a threshold value, and the threshold value also will be there in between the two values. That is generally we are pointing it as a 0.5. So any value that is above to the 0.5, that will be considered as a 0.1. 1 will be there. So any point below the 0.5, that will be 0. So here is a figure. In this figure, we can see the logistic regression between the score, class level, and probability of passing. So on the basis of that, the regression model created for the performance of past participants. So they are having this is the regression line actually, that will that is a logistic regression. So this is a sigmoid type of line is there. So in that, the threshold value will be there here, 0.5, right? So like this, the regression is pointing. The regression is having all the points in this. Next is when we will use the classification, on what point we are going to use the classification model. So classification is used when your target is categorical. First thing, categorical, while it is a supervised learning algorithm also. The examples of classification problem that can include the predicting yes or no. There will be the two type of class levels, estimating the gender, that will have male, female and third gender, breed of an animal, any type of birds will be there, and type of colors, how many types of colors are there. So these are the simple examples of classification problem. Explain Bayesian classification. So Bayesian, that is working on a Bayes theorem. That will work on the Bayes theorem. So a Bayesian classifier is a statistical classifier. They are going to predict the class membership probability. For example, the probability that will be given to the sample that is belonging to the particular class, that is normally it is going to belong to a one class. So Bayesian classifier, it is going to create on the Bayesian theory, Bayes theorem. What I said, Bayes theorem. That is in the mathematics. So a sample Bayesian classifier is known as a name-based classifier that will be compared to the performance with the decision tree as well as with the neural network classifier. Bayesian classifier, it is having also the higher accuracy and speed when it is going to apply for the larger databases. So the Bayesian classifier that is going to use very, very accurately. So that was all about the today's class, in which we have discussed some question from the question bank that was related to the classification and prediction. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.